And this video is on place value patterns, especially in regard to when you're being asked to compare different numbers or parts of numbers. For example, you might see questions like, sorry, that's not a question, like how many times bigger is this number than this number, or how many times bigger is the 5 in this number compared to the 5 in that number. Um, you might see a question like the digit in the ones place is blank times as much as the digit in the tenths place or the digit in the hundredths place. You might see a question like, what number is 10 times as much as another number? Or they'll give you a number. 328 is 1/10 as big as what number? This video is going to help you understand all those questions. So the first thing that we need to do is just review the most fundamental part of the place value chart. And that is this, that every number has a value that's based on its place, and that each place is 10 times bigger than the place to the right. So for example, if I have a 5 here in the ones place, I know that if I move it one place to the left, that number is now worth 50. If I move it, which is 10 times bigger, right? So the tens place is 10 times bigger than the ones place. The hundreds place is 10 times bigger than the ones place, the tens place, I'm sorry. The hundredths place is 10 times bigger than the tens place, and 100 times bigger than the ones place. So every time you move over one place to the left, it gets 10 times bigger. If you move 2 places, it's 100 times bigger. If you move over 3 places, it's 1,000 times bigger. So moving to the left each place gets 10 times bigger each time. The same thing happens if you move to the right, and that's where we have decimals. So just let me back up here. And if you move to the right, and we have the decimal point right here, you get to the tenths place. So this 5 here would be worth 1/10 as much as it would be if it was in the ones place. Okay, and then of course the next place after that becomes the hundredths place. Let's see if I can write this or not on an angle. All right. Okay, so if we move a 5 over from the ones place to the tenths place, it's 1/10 as big. And if you move from the ones place to the hundredths place, it's now 1/100th as big. So this 5 here is worth 1/100th of that 5 there. That's the thing that we need to just keep in mind as we're looking at any of these types of problems. When you move to the left, each place gets 10 times bigger. When you move to the right, each place gets 1/10 as big, which is sometimes said as 10 times smaller. 2 places is 100, 3 places is 1,000. Let's take a look at some examples. How many times bigger is, and here are 2 different numbers. I said this in the other videos, and I'll say it again. You need to take the couple of seconds that it will take to rewrite the numbers in a way that they are lined up so that each place is lined up with the same place in the other number. So we have 57,832 and 5/10. I'm trying to neaten that up just a little bit. Okay, and we have 578 and 325 thousandths. And it's asking you how many times, there we go, how many times bigger is this number compared to this number? Well, let's take a look. First of all, we need to make sure that they are exactly the same digits, 57832.5, 578.325. So it is. So it is just the same number. Everything is just shifted over, and we need to see how many places is it shifted over. So let's take a look and see the 5. We just use the first number, or the first digit rather. It's shifted over 2 places. Okay, let me actually do that in another color so we can see. The 5 is right now in the smaller number, it's in the hundredths place, And if we go over, it is in the 10,000s place in the bigger number. So it is shifted over 2 places. Now remember, if you go over 1 place to the left, it's 10 times bigger. If you go over 2 places to the left, it is 100 times bigger. Okay. A quick way to remember that is, you go over 1 place, you're using, it's 10 times bigger, which has 1 0. If you go over 2 places, it's 100 times bigger, which is 2 zeros. If it was 3 places over, it would be 3 zeros, so it would be 1,000 times bigger. Okay. The trick here, it's not really a trick, but the key is line up your numbers and then just count how many spaces it is over, and that'll tell you how many times bigger it is. Okay, let's look at another type of question. Here, instead of looking at the whole number, like we did in this, we want to look at particular digits. So, this question says, in the number 5,482 and 4/10, the digit in the hundreds place is blank as much as the digit in the tenths place. So the first thing we want to do is identify them, right? So the digit in the hundreds place, that is this guy right here, and the digit in the tenths place is this one right here. Okay. Again, this only works if they're both 4s, so we know that the digit is just shifted over. It's not changed. So we want to say, how much bigger is it? So we know that hundreds are bigger than tenths, so we want to count how many places it is. So we start in the tenths and we say we moved over 1, 2, 3 places. Okay. Now remember that. Don't get fooled and jump to an answer and say, oh, it's 3 times as big. It's not 3 times as big. Each time it moved over, it got 10 times bigger. So the first time it got 10 times bigger, then it got 100 times bigger, and then it got 1,000 times bigger. So if it moves over 3 places, it is 1,000 times bigger, which means that our answer is 1,000 times as much as the digit in the tens place. Okay. You could get a very similar question where it's going the other direction, though. In the number 752 and 5/10, here it's saying the digit in the tens place is blank as much as the digit in the tens place. So here we're starting with the tens place and we're saying how much is that compared to the one in the tens place. So now it's actually getting smaller, right? This one is smaller than this one. So it's not 10 times as much or 100 times as much, it's a fraction as much. It's smaller. So this is something that definitely gets confusing with students. So I want to slow down just a little bit. It's asking you how much the digit in the tenths place, which again is this one, and that's saying how much as much as this one. Okay, since it's smaller, we know our answer is going to have to be a fraction. So the question then is just what fraction? Well, from the tens place to get to the tenths, you have to move over 1, 2. Okay, if we move over 1 to the right, it's 1/10 as big. If we move over 2 to the right, we know it is 1/100th as big. Okay, 1/100th as much means smaller. Okay, if the 1/100th, 1/10 stuff is confusing you, I'm going to try to make another video that just talks about that. If look for it, if it's there, you can watch it. If I don't get to it, I'm sorry. Right. Another type of question, what number is 10 times as much as, and then you get a number, so here we have 280 and 4/10. So again, we want to start with that number, 280 and 4/10. To make a number 10 times as big, you're just going to shift the whole digit 1 place to the left. So we have this number, the 2 goes from the hundreds place to the thousands place. The 8 goes from the tens place to the hundreds place. That 0 has to go from the ones place to the tens place, and the 4, and remember it's getting 10 times as big, so it goes from the tenths place to the ones place, and we wind up with 2,804. Okay, so that's 280 and 4/10 times 10, is 280.4. We could do the same thing if it was times 100, only we would shift everything 2 places. 280. Sorry, that should be 4. 4, 0. Okay, we can put that 0 in the tens. We don't really need it. The important thing is just to look and notice that if we're multiplying by 10, everything's shifted over by 1 place. Okay, and if everything, and if we're multiplying by 100, everything's shifted over by 2 places. Okay, you can do kind of a shortcut here, and I'm just going to show you that real quick. Okay, if you understand that the decimal place really doesn't move, decimals can't move. They are showing you the border between whole numbers and decimals. However, if you understand that the digits are moving to the left, you can say, well, if it's getting 10 times bigger, it's going to look as if the decimal moves to the right 1 place. So you could just do that and then rewrite the number as 2804 decimal. If you were doing it to the times 100, you could do the same thing in Serial. The decimal's got to move over 2 places to the right, and you get 28040. Okay, just keep in mind, digits move to the left as numbers increase by 10, 100, 1,000, whatever. But you can make it look like the decimal point moved to the right because it comes out to the same thing. Okay. And now we've got one of these divided by 10 things, which is exactly the same type of deal as before, only the digits are moving the other way. So if we have this number, 280 and 400ths, and we want to divide that by 10, we know that everything has to move to the right because it's getting smaller. We're dividing by 10, and because it's 10, it's moving over 1 place. So our number would become 28004, or 28 and 4 thousandths, because everything's shifted over 1 place. That's divided by 10. If we're dividing by 100, everything would shift over 2 places. So the 2 would shift over to 1's place. 8004. A really important thing is don't lose track of these zeros here. They are important because they're in the middle of the number. Okay? You could do the same thing here if you wanted to also. If you just want to say, all right, well, if I'm dividing by 10, all the digits are going to move to the right because it's getting smaller. So it's going to look like the decimal moved to the left. So you could just say, all right, you know what? I'm going to go ahead and just move the decimal 1 place to the left to show that it got 10 times smaller. And we might remember this one. 28 and 400ths. Okay? If I'm doing it times, 100, same thing. I can move all the digits 2 places to the right, or I could just say, well, the same as moving 2 places to the left. Decimal. Either way, the important thing here is that I'm writing the numbers over and I'm showing the movement. All right, we have one technical question left here. 58 and 2/10 is 1/10 as big as what number? This is a hugely confusing question for a lot of students, okay? And again, I'm going to try to do a different video that just talks about the whole idea of 1/10, or 1/100. The point is this, I'm starting with 58 and 2/10, and I want to know that's 1/10 as big as what? Well, if 58 and 2/10 is 1/10 as big as something, that something has to be bigger than 58 and 2/10. You know, if I said to you, well, I ate 1/4 as much pizza as my friend, I know my friend ate more pizza than I did. So I know that that answer is going to be bigger than when I started with. But I said, don't let that part confuse you. If 58 and 2/10 is 1/10 as big as what number? I need to know a number that is bigger than 1/10. How much bigger? Well, it's going to be 10 times bigger, because that's how I got to 1/10. So, again, let's start with our number. 58 and 2/10. And think, well, what is this 1/10 as big as? Well, that means what number is 10 times as big? So everything is going to move over to left. I need to figure out what's bigger than this that I can get 58 2/10 to be 1/10 of. So one thing that I really, again, need to stress, besides writing it out, putting it down on paper, showing the numbers, is this. I just wrote an answer here. I now want to check and make sure that answer makes sense. So I'm going to come up here and read this. 58 2/10 is 1/10 as big as 582 2/10. And I want to make sure that makes sense. This number is 1/10 as big as that? Yeah, that absolutely makes sense because this is smaller. If I had made a mistake, which a lot of students will make, and done this backwards and said, oh yeah, all I have to do is just, move everything over one place, and done this, and move the decimal the wrong way or move the digits the wrong way, then I would be saying 58 2/10 is 1/10 as big as 5 82/100. And that's where you've got to stop and say, wait, that doesn't make sense. How can something that big be 1/10 as big as something smaller? So please, after you do these problems, if you're having trouble with them, go back, reread the whole thing with your answer in there to make sure that it makes sense. Okay. Hopefully that helps. Watch the video again if you need to, and try out some problems for yourself.